Okay, it's 1 p.m. So before I start the lecture again, anything that any of you want me to discuss? How are you finding the course so far? Pwede bang ano? May I hear people? May I hear comments from people? Kumusta na kayo? How are you doing? Uh, Feedback lang. So there's a comment, hectic with the weekly prob sets. Well, you've only had 2 so far. No? And I think ang problema nga, kailangan humabol tayo, ano? Because medyo na ano, no? Medyo nalilihis. Challenging. A bit challenging. Sinong nahihirapan ng husto sa problem set, no? Maybe raise of hands. Baka there's something that you want me to clarify? Anything you want me to further clarify? So actually, ang feedback na nakukuha ko right now is manageable naman. No? I'm getting some feedback. Manageable naman. Kailangan lang talaga ng practice. Actually, totoo naman yan for engineering in general. You don't really learn. You don't really learn until you try to apply what you've learned. Excuse me for a few seconds. Yeah, as I was saying, no, in engineering in general, you don't really learn unless you try to apply what you've learned. So talagang kailangan practice. You have to practice. You have to try to solve problems because that's really how you learn. Hopefully, UVLE becomes a bit more stable now. I heard that they're having some problems. So hopefully ma-solve yung mga problema nila. Nawala siya ng sandali uli this morning pero bumalik naman kaagad. So no questions? I'll give it a few more minutes before we start the next lecture, just in case people have questions. May question dito, no? Walang quiz for last week. Meron. In fact, yeah. There's going to be a quiz too. In fact, it's already in UVLE. It's just that it hasn't been released yet. It's going to be released tomorrow at 12 noon. And the deadline that was set is, I think, Saturday. No? So Wednesday to Saturday. And then the problem set has already been released. I would suggest, baka mas maganda, no, unahin nyo yung quiz kaysa sa problem set. Yeah, kailangan, ano, no? So there's a question again. Kailangan ba sagutin ang quiz 1 sa UVLE kahit na nagpasa na ng problem set? Remember that your quizzes are graded. That's part of your grade. Okay? So you have to complete the quizzes. Otherwise, kung hindi nyo matapos yung quizzes, you're going to get a 0 for that. So you have to do your quizzes. Ang basis for grades nyo is if I may review it with you, you have 3 exams, so that's 25% each, and then your quizzes and your problem sets, that's the remaining 25%. I think it's 10% for the quizzes, 15% for the problem set, or the other way around. No? I have to go back to my notes, no. But importante yung quizzes. Engineering notation. No, I don't think so. No, if it's 2 or 3.5, you don't. Engineering notation is very flexible, actually. Ang engineering notation lang is when you have numbers that exceed 1,000, then you have to express it already in in terms of powers. May definition naman ng engineering notation dun sa quiz eh. I think those are 0.05 or 500 milli. Those are both acceptable. Those are both acceptable. But no, don't trust me on that, no? You look it up actually. Kailangan i-look up ko rin yun. Ang dapat yung tandaan sa engineering notation is your power, the power of yung times 10 to the power, yung power should always be divisible by 3. That's what you have to remember. That's why your number can be anywhere from your base number can be anywhere from 0 to 999. So yung exponent ng 10 should always be divisible by 3. So that's consistent with yung mga milli, mega, no, micro, nano, kilo, and so forth. That's what you have to remember sa engineering notation. Okay, there are already 27 of you here, so I might as well start. No? Otherwise, sayang naman yung oras. I said I'd start at 1:15, but if all of you are here already, let's well start. Okay, so this afternoon we're going to discuss nodal analysis. This is a summary of what I'm going to present to you this afternoon. I'm going to discuss the general procedure, and then we're going to discuss some variations of nodal analysis depending on the type of circuit that you're dealing with. No? So first, what happens when you have a floating voltage source. Second, what happens when you have dependent sources. And third, what happens if you have floating dependent sources. So ano lang, no? We discussed some levels of complication when you use nodal analysis. So this is just a review of what I already introduced last week. Nodal analysis is a systematic method of analyzing circuits which reduces the number of simultaneous equations needed to solve for all required circuit quantities. If you recall last week, the number of simultaneous equations we usually have to solve is equal to the number of essential branches whose currents are not known. Naalala niyo yun, no? If you have a circuit, it has, let's say, 10 essential branches. In those 10 essential branches, we do not know the current of, let's say, 9 of the elements. Then those are our unknowns, those 9 currents. And therefore, you need 9 equations in 9 unknowns to solve. No? So ang dami, napakadami talaga. Okay? So this is the motivation for nodal analysis. Typically, the number of simultaneous equations needed would be equal to the number of essential nodes minus 1. Number of essential nodes minus 1. So if in my circuit earlier that had 10 essential branches, if there are only 5 essential nodes, then typically we would only have to solve for 4 simultaneous equations. Now, the method is based on the fact that if you know all the node voltages in a circuit, you can solve for any branch voltage. Okay. So just to illustrate that, sorry. Just to illustrate that, let's say I have this portion of my circuit. I have this portion of my circuit. These are my nodes, no? My nodes A, B, C, D. Okay. VA, VB, VC, and VD are the node voltages with respect to a reference. So somewhere in the circuit, somewhere, we have a reference. And VA, VB, VC, and VD are the node voltages with respect to a reference. So if I know these node voltages, kung alam ko yung VA, VB, VC, VD, what is the voltage between A and B? VAB is just VA minus VB. Okay. VCA is just VC minus VA. This is by virtue of Kirchhoff's voltage law. VCA is equal to VC minus VA, and so forth and so on. No? So that is what I'm saying here. If you know all the node voltages in a circuit, you can solve for any branch voltage. Okay? And if the branch is a resistor, you can express the branch current in terms of the node voltages. So again, no? Let's say I have a resistor R, I have B. No? So anyway, and so forth. No, that's a circuit. Okay. If I know VA and VB, if these are known, okay, VAB is equal to VA minus VB, and therefore I is just VA minus VB over R. This current will be the voltage across the resistor, okay, will be the voltage across the resistor. So the voltage across this divided by the resistance value. So this is going to be useful because in nodal analysis, we're going to be applying Kirchhoff's current law. And Kirchhoff's current law requires that you have an expression for the currents that flow into or out of a particular node. So this is how we're going to do it. Okay, so let me outline the general procedure, although this is not going to mean much to you until we actually try to exercise the procedure. So first, we label all essential nodes in the circuit. And then if a reference node has not been designated, you select a reference node. Usually you put a ground symbol or you attach a ground symbol to the reference node. And we can select any essential node to be the reference node. Although later on, we're going to see that usually there's a natural inclination on what reference node to select. No? Usually, the reference node would be the negative terminal of your power supply, for example, or your sources. That is if you have one source. No? But anyway, the rule is you can select any node to be the reference node. And then you assign, there's a question. Is there something wrong? What will happen if a non-essential node is selected? Actually, you can select a non-essential node to be a reference node. You can, no? There's no problem with that. Okay, the only reason why we deal with only essential nodes is when you deal with non-essential nodes, you're kasi, okay. So this is a non-essential node, no? Okay. If I deal with this non-essential node and I apply KCL to this node, because in this procedure we're going to be applying KCL to the nodes, then all I'm going to get is this current is equal to this current, no? I1 is equal to I2, no? So actually there's no point, no? Because the current is the same. Because if we deal with non-essential nodes, then we're going to be defining a current for this branch and a current for this branch. But those two currents are going to be the same anyway. So parang sayang lang. You're just going to be adding an equation when you don't really need to. That's the only reason why we don't usually deal with non-essential nodes. But actually you can. In fact, later on, I'm going to give you an example where there's going to be a non-essential node which we're going to deal with. So there's another question. Does the ground affect the values in the circuit? No, the ground will not. The ground will not affect the value of the branch voltages and the branch currents. The ground only establishes a reference for the node voltages and node current for the node voltages. No, there's no such thing. No, so the ground establishes the reference for the node voltages. But if you take a look at all the branch voltages and branch currents, that will not be affected by your choice of the ground. No? So anyway, going back, no. So you assign a node voltage variable to each of the remaining essential nodes. So remember, let's say you have n essential nodes. Yung isa is going to be the ground, and therefore you have n minus 1 remaining essential nodes. You will assign a node voltage variable to each of those remaining essential nodes. And then the fourth step, you identify the node voltages which can be determined by inspection. Okay, and then for the remaining essential nodes, you write the appropriate KCL equation with currents expressed in terms of node voltages. Okay. And then finally, you solve the system of equations. You solve the system of equations. And then you solve for the required quantities from the node voltages. So the best way for us to study the node voltage method is by means of an example. So here is my example. Find the voltage Vx using nodal analysis. So what I'm trying to find is the value of this V sub x, the voltage across the 30 ohm resistance. So let's do this slowly. Let's do this slowly. Let's do this step by step so that you can absorb the procedure. So the nodes, let's designate the nodes as A, B, C, G, and G. No? So if you count, how many essential nodes are there here? There are 4 essential nodes. No? You have this node, this node, this node, and the entire bottom line is just one node. This is just one node. So sorry about that. So let's label them A, B, C, and G. And then we designate node G as the reference node. So lagyan natin ng ground symbol para alam natin na yun yung reference node. So what are our variables? What are our variables going to be? The variables are going to be VA, VB, and VC. These are our variables. Okay. So how many node voltages do we have? 3. Okay. So theoretically, how many solutions or how many equations do we need to set up? If you have 3 unknowns, how many equations do you need to set up? Tatlo rin, di ba? You have 3 unknowns, you need 3 equations. But take note, no? The value of VA, itong VA, can be determined by inspection since it is constrained by the 4.8 volt voltage source. Because itong 4.8 volt voltage source is connected between node A and node G. No? And therefore, VA minus VG must be equal to 4.8. But VG is equal to 0. No? We say that the ground or the reference node has a 0 potential. The reference node has a 0 potential. In fact, parang sinasabi natin dito is VG is equal to 0. So itong 4.8, no, you have VA minus VG is equal to 4.8, or VA is simply equal to 4.8 volts. That's what we have here. So if you go back to the procedure here, ito yung step na to, no? Identify the node voltages which can be determined by inspection. So we have found here that the node voltage VA can be determined by inspection. It is equal to 4.8 volts. So, ilan na lang ang natitira nating unknown? Ilan na lang? Medyo trivial question. Dalawa na lang, no? I just want to make sure that you're following. No? So, dalawa na lang ang natitira nating unknown, VB at saka DC. Okay, so what do we do, no? To B and C, to node B and to C, we apply KCL. No? Kasi alam na natin yung A eh. Alam na natin yung VA. So we only have to apply KCL to node B and to C. So let's do that for node B. Okay. Let me apply KCL to node B. Okay. Remember I told you the usual convention is if you do not know the direction of current, no, in a branch, and you are at node B, then you assume that the current is moving away from node B. No? But that's just an assumption. No? So dito, let's say you have this current. Let me use a different color. Okay, so here I have this current, and this current. Okay, let's call this I1, I2, and I3. Okay, so what is my KCL equation at node B? My KCL equation at node B is I1 plus I2 plus I3 is equal to 0. But what is I1? I1 is VB minus VA all over 30 ohms. Okay? VB minus VA divided by 30 should give me itong value ng I1. Okay, what is I2? I2 is VB minus VC over 10 ohms. Okay, and then what is I3? I3 is just VB over 15 ohms. This is equal to 0. Okay, so that is my KCL for node B. Let me erase some things. Okay, buurin ko ngayon to, no? Okay, so let's now do KCL for node C. Okay, this time diretsoin na natin, ano? What are our currents sa node C? You have this current, you have this current, and then of course the current from the 0.2 ampere source. Okay, ito sa taas. What is the expression for this current? Okay, you have VC rather, minus VA all over 40 ohms. Yeah, ano, no? I'm glad that some people are following. That's right, no? What is the expression for this current? Okay, you have VC minus VB over 10. And then what's your expression for this current? That's VC over 20. Okay, what about this current? This current, you don't have an expression, you know what this value is, right? And it is entering the node. It's entering the node, meaning to say ang value niya would be negative. So this is minus 0.2. This should be equal to 0. Okay. Note that itong VA, alam ko tong VA, no? VA is 4.8. Okay. So this is 4.8. So how many unknowns do I have? I only really have two unknowns. My two unknowns are VB and VC because VA is equal to 4.8. So these are two equations, two unknowns. Because VA is known. Sorry, VA is known. So madali na natin masosolve yung two equations in two unknowns. Okay. So this is just repeating what we already did. Okay. So for node B, you have the equation which we worked on. For node C, you have this equation which we worked on. VA is known, so we can solve for node B and node VB and VC. So at this point, it is no longer an EE problem. It is already an algebra problem. And if you put the two equations in standard form, then you can get your calculator to solve it for you. You don't even have to do any algebraic manipulation anymore. Gamitin na lang niyo yung calculator ninyo. So we're going to get this, no? We're going to get this VB is equal to 2.4 volts and VC is equal to 3.2 volts. So now I know all the node voltages. I can get all the resistor currents, and I can compute for all the resistor voltages also. In other words, any unknown in my circuit, I can solve for. Okay, what is being asked for? Ang hinihingi sa problem is Vx. So what is Vx? Vx is simply VA minus VB. So solving for Vx, I get 2.4 volts. Okay. Any question? So ano yung kagandahan nitong method na to? Okay, if we had used the technique we learned last week, you have how many essential branches here, no? You have 1, 2, 3, 4, 5, 6, 7. You have 7 essential branches. 1, 2, 3, 4, 5, 6, and 7. You only know one current, and that is the 0.2 ampere. So actually, you have 6 unknowns. Okay. So if you wanted to solve for all the currents in the circuit, you would have to solve 6 equations in 6 unknowns. But notice here, we only ended up solving 2 equations in 2 unknowns. So what would you rather do? What we did last week or what we did now? No? Not to say that what we did last week is totally unimportant, because for me, it's a good segue into this. You still, sometimes you still have to do things I guess the KCL KVL way. No? But whenever you can use the node voltage method, it's much easier to use the node voltage method. So there's a question here. Sa problem set, need bang ilagay yung solution algebraically para mahanap yung unknowns? um, maybe you can put a note there, no? That using your calculator, you came up with the following values. Siguro naman maintindihan na yun ng checker. Okay? But then you have to set up all your equations. If I were you, I'd set up all the equations. And then you just put a note, no? Using your calculator, this is what you came up with. Okay, there's a very good question here. I was hoping somebody would ask it. How do we know kung tama yung assumption natin ng direction of currents na pinili? No? Okay. That's a very good question. Okay, so let's say I'm setting up let's say KCL here, no? KCL. So let's say this is VA, that's VA, and this is VB. Okay. Let's say this is already known, no? Ito I1, ito I2, sabihin natin I3. Okay. So what is KCL here? Let's say I assume that this is the direction of current. Okay. So if I apply KCL to A, to node A, what will I get? I'm going to get I3, okay. Ano bang direction ng I2? I forgot to assign a direction to I2. Let's say this is I2, no? Okay, I'm going to get I3 plus I2 minus I1. Okay? Kasi yung I1 papasok, no? Yung I3 palabas, yung I2 palabas. Okay, ito palabas din sa node. Palabas din yan sa node, no? So what is my expression for that particular current? Okay, so that's going to be plus VA minus VB over R. So let's say this is R. This is equal to 0. Okay, what if, sorry, I lost my page. I lost my page. Ulitin natin. No? This is R. Okay, this is A, this is B. Let's say I have this, no? I1, I2, I3. And then here I assume this is the direction of current. So again, what is my equation here going to be? It's going to be I1, okay, plus I2 minus I3, okay, plus VA minus VB over R is equal to 0. Okay. Now what if ito yung assumed direction ko ng current? What is my equation going to be? My equation is going to be I1 plus I2 minus I3. So pareho, no? I1 plus I2 minus I3. Now, what is this current? This current now, since it is right to left, this is going to be minus, ano? Because it is right to left. So it's entering the node. But this is going to be VB minus VA over R. It's equal to 0. Compare the two equations. What do you notice about the two equations? What do you notice about the two equations? They're the same. These are the same. So what am I saying here? It doesn't matter. No? You can assume either direction. Because whatever direction you assume, you're going to get the same expression. But mas maganda para sa akin, ano? Of course, this is a matter of choice. Mas maganda kung ito yung gamitin nyo. No? Because if you assume that the current is always going outward, then your term is positive. And I think you're less prone to make mistakes when your term is positive. But that's just a choice. That's a choice that you can make. You can assume the direction to be outward, or you can assume the direction to be inward. Note that as you go from node to node, you can change your assumption. Notice that in our, okay, mabubura na to, okay. Notice that here, for example, here, ano itong current na to, no? This current is from B to C passing through the 10 ohm, no? So this current actually corresponds to this. No? But if you take a look at this current is from C to B passing through the 10 ohm. No? So if I do here, parang pa ganyan. Right? So the assumed direction of current here is different from the assumed direction of current here. It does not matter. It does not matter. Okay, so from when you go from node to node, you can change the assumed direction of current. Okay, so that is the nice thing about the method. Okay, okay, so let's take up some more examples. Okay, this is a complication that you can run into. The case of having a floating voltage source. Okay, so for the circuit shown, determine the voltages VA, VB, and BC using nodal analysis. So, ito no, ito na yung tatlong essential nodes natin, VA, VB, DC, and then this whole node in the bottom, this is what we make our reference. Okay. So, ilan ang equation na kailangan natin? We have 3 unknowns. You need 3 equations. 3 unknowns, 3 equations. So, yung equation for node A, let's do the equation for node A, no? Madali lang to. Okay. So, the equation for node A, let me do it here. What will my equation be? Okay, yung current dito sa 8 ohms, what will that be? That will be VA minus VC over 8. No? Moving away from node A, so positive. Yung current dito sa 6 ohms, okay, so that's plus VA minus VB over 6. Okay, ano pa yung isang current natin? Yung isang current natin is this 3 ampere source. So is that plus or minus? Okay, may sumagot na, no? It's minus. So minus 3, what will that equal to? That will be equal to 0. Okay, that's my equation for node A. Okay. Subukan nating gumawa ng equation for node B. Let's try writing an equation for node B. Okay. So I have this current, yung bumababa dito. So what is that? That's VB over 3. No? Plus, I have the current that is flowing from B to A through the 6 ohm. So that's VB minus VA over 6. Tapos na ba? So tanong ko, tapos na ba? Yes or no? No. Bakit? Why are we not yet finished? Okay, there's another branch. That's right, no? Sabi ni Alia, there's another branch. So there's this branch, no? Okay. So what is this? Tell me if I'm correct or not, no? Tama ba ito? Minus 6 is equal to 0. Tama ba yan? Okay, why is it wrong? Why is it wrong? Because we are supposed to be adding currents. No? This is a current. Itong term na to, that's a current. This is a current. Ba't tayo mag-a-add ng voltage sa current? You cannot add voltages to currents. You add currents together in KCL or you add voltages together in KVL. But in an equation, do not mix up voltages and current. So obviously, mali ito. No? Mali ito. That's wrong. So, what am I going to put there? Yun ang problema natin. No? Sorry. That is our problem. I have a current flowing here. No? Let's call this I 6 volts. Okay, so I have here minus I 6 volts. That's equal to 0. But what is happening here? I'm introducing a new unknown. This I 6 volts, you're introducing a new unknown. Dati-dati tatlo lang yung unknown natin, VA, VB, VC. Ngayon, pag ginawa natin to, we are introducing a fourth unknown. Meaning to say, we need an additional equation. So I don't want to do this. I don't want to do that. Okay, so you see it, no? Can easily form the KCL equation for node A, so we already did this. VA minus VC over 8 plus VA minus VB over 6 minus 3 is equal to 0. We cannot apply KCL to either node B or node C without introducing a new unknown variable, which is this, the current flowing through the 6-volt voltage source. So what is our strategy here? The strategy is to combine node B and node C into what we call a super node to which KCL is applied. So itong voltage source na to, okay, in effect, no, yung node B and node C, we combine into a super node. Actually, hindi ko kailangan malaman, in applying KCL, I don't have to know what is inside this. No? So I can actually hide the inside of that, okay, and then I apply KCL here. What is my rationale there? No? If I have a super node, so let's say this is a super node, I have currents going in and currents going out. I1, I2, I3, I4, let's say I5. Okay. Minus I1 plus I2 minus I3 minus I4 minus I5. This should be equal to 0. So KCL will apply to this super node. And that's because charges cannot accumulate in any part of the circuit. So if we define this whole thing to be a super node, we can apply KCL to that because of the rule that charges cannot accumulate in any portion of the circuit. So that's what we're going to do here. Again, no? Remember what I said, that you don't even have to know what is inside for you to apply KCL. So the KCL equation for the super node, what are my currents now? Okay, I have this current. So what is that? That's VB minus VA all over 6 ohms. I have this current that is plus VB over 3. Okay, this is another current moving away from your super node, this one. Okay, so that's plus VC minus VA over 8. This is another current plus VC over 4. Then finally, I have this current source going inside my super node. So this is minus 5. This is equal to 0. So that's the KCL equation for the super node. Okay, that should be consistent. VB minus VA over 6, VB over 3, VC minus VA over 8, VC over 4 minus 5 is equal to 0. Okay. So dito, we have one equation, okay, from node A. Okay. Dito, we have another equation for the super node. There seems to be a question. Yeah, no. I said, so may tanong dito, no? Always away from the node ba yung mga equation, no? I think you're referring to the currents. I said for me, that's the easiest. You always assume that the current is moving away from the node if you do not know the direction. If you do not know the direction, you always assume that the current is moving away from the node. Para mas madali. Para mas madali. Kasi pag ginawa niyo yon, yung terms mo will always be positive. your terms will always be positive, no? Dito, alam na natin yung direction. So alam na natin na negative yan. But if you always assume that all other currents are moving away, then all your other terms will be positive. And like I said, if we make the opposite assumption, the two equations are going to come out exactly the same. I already pointed that out earlier. Okay, anyway, going back. I have two equations, but how many unknowns do I have? How many unknowns do I have? 3. VA, VB, and VC. So, kailangan ko pa may kulang pa ako ng isang equation. Saan ko kukunin yung isang equation na yon? Anyone? Any idea from anyone? Where do I get the third equation? Meron isang quantity dito na hindi pa natin nagagamit. So there's a suggestion here, no? Kukunin sa ground. You remember what I said? You remember what I said before? No? That when you have n essential nodes, you can only form n minus 1 KCL equations. Right? So dito, pag nag-form ako ng KCL equation dito sa ground, it is not going to be independent of my previous KCL equations. So we had that discussion before. So hindi pwedeng gamitin yung ground. So ano ba yung mga ibang sagot dito? Doon sa 3 ampere source, ito ginamit na natin, no? Ginamit na natin tong 3 ampere source doon sa equation 1. If you look at the previous slide. Okay, so ano pa yung information na hindi natin ginagamit? The information that we haven't used yet, that doesn't appear anywhere in our equations, is this. Is the 6-volt source. No? That hasn't appeared yet in our 2 equations. So hindi pa natin nagagamit yung information na yan. So gamitin natin yung information na yan. What does the 6-volt source do? It forces the difference in voltage between node B and node C. Pag linagay natin yung 6-volt source between node B and node C, pinipilit niya na VB minus VC is equal to 6. Okay? So that is where the third equation comes from. No? So the third equation can be obtained from the constraint imposed by the 6-volt source on nodes B and C. That is VB minus VC is equal to 6. So those are now my 3 equations. Okay. So yes, some people saw that, no? VB minus VC is equal to 6. So 3 equations, 3 unknowns. I just solve it simultaneously. So like I said, put it in simplified form, enter it into your calculator, and you're going to get VA is 24, VB is 16.3, and VC is equal to 10.3. Okay. Kaya yan tinawag na floating voltage source. The reason why we call this a floating voltage source is because neither of its terminals is connected to the reference node. That's why it's called a floating voltage source. If either the positive terminal or the negative terminal were connected to the ground, then it is no longer considered to be floating. Any question with regard to this example? Okay, let's take this example. So this is another example. Use nodal analysis to solve for the power dissipated by the 2K resistor. How many essential nodes do we have? How many essential nodes do we have? May I hear some answers? 2. Okay, 2, 2, 2. So lahat sumagot ng 2. Tama, 2. Daming sumagot ng 2, no? So this is 1, and then this is the other. Okay. You have a node here, but it is non-essential. You also have a node here, but it is non-essential. So pag Pag isa lang yung essential node mo, pag dalawa lang yung essential node mo, how many KCL equations can you form? Isa lang, right? Remember, if you have n essential nodes, you can only form n minus 1 KCL equations. Okay, so let me label some voltages in this particular circuit. Ano? So this is my essential node. That's the unknown that I want to solve for the meantime. Ano? Remember, the problem is to get the power dissipated by the 2K resistor. No? Ang strategy natin dito is solve for this unknown. And then if we know this unknown, we can now get the current through the 2K resistor, and therefore we can solve for the power. Or we can simply say VA squared over 2K is the power dissipated by the 2K resistor. Okay, so there are only two essential nodes in the circuit, node A and ground. We want to solve for VA by applying KCL at node A. However, the currents I1K, so itong current na to, and I2V, ito, this current, are not immediately obvious. But actually, pag nasanay kayo sa circuit analysis, you're going to see that it's very easy to compute for I1K and I2V. Anong value ng I1K? Anyone? What is the value of I1K? In terms of the circuit quantities that you see. No. Thank you for attempting to answer. No. So a lot of people answered 8MA. No. Remember, no. Because that's a common mistake. So I'm glad you answered that. No. Remember that 8 volts is not the voltage across 1K. Okay? Itong 8 volts is not the voltage across this 1K. When you apply Ohm's law, V or I is equal to V over R. Okay, this should be the voltage across R. And then this is the current through R. Okay, so nice try for those people that answered 8MA, but unfortunately 8 volts is not the voltage across 1K. And like I said, I'm glad that some people answered that because that's a common mistake that students in early students in Triple E make. No? So, tama, no? A lot of people now were able to get it, but not everyone, no? I want an expression for I1K. I1K is actually VA minus Vx over 1K. But Vx is equal to 8 volts. If you take a look at this Vx, that is just equal to 8 volts. No? In other words, even if this is not an essential node, this is a node voltage. Itong X is not an essential node, but it has a node voltage. And this node voltage, you can determine by inspection. Because Vx minus Vg must be equal to 8 volts. So I1K is just really VA minus 8 over 1K. Now, what is I2V? Okay, so I2V, ano naman ang I2V? Let's see if you can get that. Ano ang value ng I2V? Not value, no? Because you cannot get the answer right away. What is an expression for I2V in terms of our unknowns in the circuit or our circuit parameters? Okay, so may nagsasabing Vy over 3K. Tama yung Vy over 3K. Pero anong value ng Vy? Remember that I really have only, I want to have only one unknown, no? I only want to have one unknown because I can form only one equation. Okay? Okay, so tama, no? I to V is Vy over 3K. So tama yan, no? But remember that VA, Vy minus VA is equal to 2. So Vy is equal to VA plus 2. So this is actually VA plus 2 over 3K. So I have an expression for I1K in terms of VA. I also have now an expression for I2V in terms of VA. So going back to, okay, so that's I1K, and then this is I2V. So I can now form the KCL expression for node A. Pwede na ako nodal analysis dito sa node A. No? So what is this? This is I1K. What is this? This is I2V. What is this? This is just this current. Is equal to 0. How many unknowns? Only one unknown. So only one unknown. So the trick is how did you form this and how did you form that? Okay. So if I solve that, I'm going to get VA is equal to 4 volts. Okay. And then from knowing VA, then power is just V squared over R. I'm going to get 8 milliwatts. Now note, no? The 2-volt source could have been treated as a floating voltage source between node A and node Y. The 2-volt source could have been treated as a floating voltage source between node A and node Y. So if I had done that, so I'm just saying there are many ways of solving this problem using the node voltage method. No? What if I had made this a super node? So ano kung ginawa ko tong super node? What will be my KCL equation for the super node? My KCL equation for the super node would be VA minus 8, no? Vx, but this is equal to 8, VA minus Vx over 1K, okay, plus VA over 2K. Okay, what's my other current? This is my other current, no? I have 3 currents associated with the super node. So my other current is, okay, plus Vy over 3K is equal to 0. I have 2 unknowns here. No? Kasi yung Vx, alam ko na. Vx is equal to 8. I have 2 unknowns. 2 unknowns, Va and Vy. But I know that Vy minus Va is equal to 2 volts. So this is one equation and this is my second equation. So 2 equations, 2 unknowns. So pwede rin ito yung solution. This is another possible solution. Actually, if I substitute this here, no, I'm going to get exactly the same equation as I got earlier using the first technique. Any questions? Any questions with respect to this? yung mga sumasagot, yun yung walang tanong. Ano? I hope that the people that aren't chatting anything, ano, no? Are everything is clear. So yeah, there's a question here. Can there be multiple supernodes? Yes, why not? There can. You can have a circuit with many supernodes. Any other question? Okay, so let's take still another example. So mostly examples ang kukunin natin. No? Here's another problem. Case of having a dependent source. So find the power dissipated in the 5 ohm resistor using nodal analysis. So ngayon ang sorry. Ang nagiging komplikasyon ngayon dito is, well, hindi naman talaga komplikasyon. Ang bago nating pinasok dito na hindi pa kayo sanay is I have a dependent source. This is a voltage source, and this voltage source is dependent on this current, I-phi. No? The voltage produced by this voltage source is dependent on I-phi. Okay. So let's go through this little quickly kasi medyo sanay na dapat kayo at this point, no? So select a reference node and assign node voltages. So this is what I did here. Okay. So this is what I selected as a reference node, and then I have a node voltage for this point, and I have a node voltage for this point. So my node voltages are V1 and V2. And then write a KCL equation for each non-reference node. So, ang KCL equation ko for node 1, okay, ano itong term na to? This term, ito, dapat sanay na tayo rito, no? So the voltage at this particular node is equal to 20 volts, right? So this, you have a node here. Sorry. You have a node here. So may pasensya na, no? Nag-act up yung ano ko. Okay. I have a node here. This voltage is equal to 20 volts because that is constrained by this voltage source. Okay, so ano yung current ko rito? Yung current dito, papunta dyan. That's V1 minus 20 over 2. So ito yung term na yan, no? V1 minus 20 over 2. Ano yung current ko rito? Papunta sa kanan. That's V1 minus V2 over 5. And then ano yung current ko pababa rito? That's just V1 over 20. That's equal to 0. And then here, I have another node here, no? Node 2. In writing out the expression for node 2, I have a node voltage here. What is the node voltage here? The node voltage here is 8 I's of phi. No? Kahit na may I yan, this is a voltage. Huh? That's a voltage, 8 I's of phi. Okay, so I'm here in 2. What is my current from node 2 to node 1? Again, going to the left. From node 2 to node 1, that's V2 minus V1 over 5. And then my current going down here is V2 over 10. And then my current from V2 to this particular node here That's V2 minus 8 IP. So again, recall this is a voltage divided by 2. Okay? So those are my two equations. How many unknowns do I have? How many unknowns? So I'm trying to check whether you're still alive. Okay, ano yung isang additional unknown natin? Itong IP, no? Kasi lumabas dito itong IP. Okay? Tama, no? May nakasagot. That's my third unknown. I only have two equations. Now, what third equation can I form? If I know V1 and V2, I can express IP in terms of V1 and V2. And that's right, somebody answered already, you know? IP is equal to V1 minus V2 over 5. So yun yung third equation ko ngayon. So 3 equations, 3 unknowns. So ito yung expression ko for IP. So I now have 3 equations, 3 unknowns. I just solve them simultaneously. I'm going to get V1 is equal to 16 volts and V2 is equal to 10 volts. So what is the problem? The problem is what is the power dissipated in the 5 ohm resistor? So knowing V1 and V2 is IP.
Video on daw, ma. Nakita niya, nabasa niya.
Tama?
Video? Ay, naku, di kayo nakikinig. Sabi nila video on daw.
Video on pa may mga question daw.
Talaga? Hindi off lang.
Sige, sabi mo. Okay, so we know IP, that's 1.2 amperes. Okay, so we can now compute for the power across the 5 ohm resistor. Any questions? Any questions? Okay, I'm going to stop there. No, I'm going to stop there. I'm going to give you time to digest these two cases. What will we discuss on Thursday? Actually, isang case na lang i-discuss ko sa Thursday, and that's the case of having a floating dependent source. But you're going to find that actually dapat kaya na nyo to, no? Using the techniques we previously studied. Dapat alam na rin ninyo how to do a floating dependent source. And then after that, we'll just be taking examples, no? After that, we'll be taking some examples. So that's all I have for next Thursday. So, any questions before I dismiss the class? So this time I was able to stick to my target of not lecturing for more than an hour. So there are some questions. Okay. So there's a question here. Ano itong question mo, Hans, dun sa floating dependent source? Yes, no? You'll actually end up having to apply the supernode. Okay. In fact, pwede na yung subukan, ano? You already have the notes. already have the notes. You can go through the notes already, and you can already try to solve that example and even the other examples that have been given. Any other questions? So last call for questions. Una, no? Last call for questions with regard to this lecture. Okay, what about any other questions you might have with regard to the previous material or with regard to the course? So just a warning, there's going to be a quiz 2 that will be active, that will start being active tomorrow. No? It will be active at noontime tomorrow. It will be due on Saturday. Yung problem set 2, after discussing with the other instructors, we decided to extend the deadline of problem set 2 to Monday, if I'm not mistaken. But then, be ready because magkakaroon na ng problem set 3 that's applicable to this week's material, and magkakaroon na rin ng quiz 3. So we're going to have to try to squeeze the schedules para makahabol kasi na-disrupt tayo ng matagal because of UVLE being down. No? So little by little, mag-a-adjust kami ng schedule. Hopefully by Holy Week, ma-normalize na yung schedule natin that the quiz be released Tuesday or Wednesday of the week of the lecture, no? And then the problem set at the end of the week to be submitted about a week later.
Oh, tingnan mo, may ginagawa sila. Ano yan?
Okay? Any questions? Natatakot ako pag walang question eh. I have no idea whether kasi pag walang question, dalawang bagay yan eh. Yung isa is naintindihan nyo lahat. Yung isa is wala kayong naintindihan. Ano? Usually yung kaso pag walang question. Either you understand everything or you understand nothing. No? So anyway, like I always said, if you have any questions and you're just ashamed to ask it, no, you can always email me also. Okay, so that's all for today, no? So I'll see you all again on Tuesday. Thursday. So thank you.
Thank you, sir.
Thank you po, sir.
Yeah, you're welcome.
Thank you po, sir.
Thank you po.